Hi folks, I'm going to talk about a little circuit I've built. It's an interface between a satellite tracking system and the antenna rotors. This is what it looks like on the experimental board that it's on. This is what's called a Parallax basic stamp chip. Comes from Parallax. This is the manual that describes how to write the software. It's written in BASIC. Also on my breadboard I have an A to D converter. It has 2 channels, and these 2 pots here, one represents the azimuth rotor, one represents the elevation rotor, and when I have this all set up, I'll have to have the feedback that's coming from these 2 pots will actually be connected to the actual rotors. Over here I have a 8-bit serial in, parallel out chip. It's taking data from the basic stamp that I want to display onto my LCD. It takes the takes in serial data, puts the parallel data onto these little LEDs. That's just for troubleshooting, and then it sends it out over this little cable, ribbon cable, down to a display. And what this is showing is the azimuth and the elevation, and the D and the C means desired and current. When I finish this project, I'll actually change it and actually put the degree symbol, but I need to do a bit more work to get that completed. There's a couple serial cables here you'll see. One is just for troubleshooting. The other one, this one here, is actually taking data that I have running in Nova. Nova is sending data right now. I have another program in the red screen. It's called PortMon. If you can't see it there, but PortMon. What it does is it actually shows the actual data that's going through the serial cable. And you know, you can't build a project like this without seeing exactly what's being sent by the PC. So right now you see a series of C2 messages, and right now the Nova is set up. It's sending what's called the Yaesu GS232A protocol, and it's actually halted right now. And I'm going to go and well, what's going to happen? I'm going to unfreeze my Nova. It's going to start sending the current coordinates of the ISS, which is currently located over Quispamsis, and you'll see a series of messages. It'll say W and then some numbers, which represents the azimuth, a space, and more numbers, which represents the elevation. This gets read by this chip, processed in memory, compared to the readings that it's taking from my fake elevation, azimuth and elevation rotator. It'll determine what to do. If it has to move the antennas, it's going to light these 4 first LEDs. The first 2 here represent the azimuth. This is turn it counterclockwise. This is turn it clockwise. The next one is turn the elevation rotor down, turn it up. So you'll see these will light up. I will use my screwdriver to change the pots appropriately, and then you'll see some action on my screen here. It'll actually show the current settings. This is where the antenna is pointing, and this is where it should be pointing. This comes straight from the serial interface, so data you see there will miraculously show up on my screen, and data that is being figured out from my elevation rotor, processed by my A to D converter, going into this chip, will end up in the second column. Let's start the whole process. You'll see what happens. So there we are. Oh, look at that, I've messed up my experiment already. Let's back up time. Great little trick. Alright, here's the ISS, coming back over Quispamsis. For that I got some data going through. Shows where the spaceship should be. And right there, look at that, we got an LED lit up. That's telling me that my rotor has to turn a bit, so I'm going to take my move the pot. I'm moving the pot, moving the pot, moving the pot. Now those LED outputs are actually going to go to a relay, which oh, look at that. So I hit the right mark. Now updated display. Look at that. It says 264 degrees, about 267 degrees. As you see, I'm watching this, it's updating. It's updating. Now you notice there's a discrepancy between my desired azimuth and my actual azimuth. I put a tolerance of 45 degrees just for the test. Of course, when I have this in practice, I'll reduce that. And you don't want to have it 0 because that'll mean that it'll be moving all the time. But some kind of small value. There you see it updated again. Now, miraculously, the azimuth data is also being sent back to Nova, and I just have to restart Nova because I've kind of messed up this test here, but to no avail. You'll see it'll all work. Right here you see where I'm gonna, let me focus on this. There you see my current settings, 254 degrees and 32 degrees. If you look over here, look at that. That was actually sent by the chip over the serial interface back to the computer, and you see a series of messages. There you can see it right there. Those are the messages sent from my basic stamp back to the computer, which then goes, and now I can sit back and relax, and I can see where my antenna is pointing, all on the computer screen, which is pretty good. I'm just gonna back up time here and set up my test again. There we are. Now we're sending some more data through. Let's see what it says now. My desired signal, 274 degrees. Oh, it's gonna update very shortly, I'm sure. You might have to hit on and off. There we are. So what I've constructed so far is a little program in in this Parallax chip. I have all the what I call the components working, so all my functions are working. And now that I have it all working and it seems to be doing what I want it to do, I now have to spend some time I need to set up the relays. So the output of my LEDs will actually go to relays, so I don't have to use a screwdriver to turn this. It'll actually be turning actual antenna rotor. I'll have the feedback come in here, and then I can just start playing with the real world example of how this is all working and tweak it out and stuff. Oh, there, now you see it updating again. 52 degrees and 12 degrees, and you see where my antenna is pointing. There you see it changing again, and there you can see on the display it says, it's kind of hard to see, apologize for that, but there my current 65 degrees and 32 degrees, and if you look right on the screen, 65 degrees, 32 degrees. So anyway, I just want to show this to guys, show this thing to you guys, because I know I've been talking about it on the air a bit, and I had a little fault in my program. I figured it out yesterday, and now I have it all figured out. Now I can just kind of optimize it, finish my relays, my interface, my rotors, and then I'll put this stuff on a breadboard. And as you can see, there's not much. I have a little 8-pin chip, a 16-pin chip, and a 28-pin chip, I think it is, or something like that. And that's all I have. A couple of resistors. You can't really tell you can't really see them probably in the camera, but not a lot to get this thing all together. I'll need a couple. Well, there's a couple components here I need to also put on a breadboard. That would be some Max 232 to TTL logic converters. So there you go. Talk to you later.